Okay, now notice GIPC is this generalized IPC mechanism I told you about. It's got NIO underneath at the bottom layer. That NIO layer can be substituted by a socket layer. It's flexible that way. On top of that, I've created RMI kind of layer. Okay, and you don't need a name server here. You can build a name server yourself. What we do is we just expect the programs to know the names. Okay, in other words, well, when you study this, you'll know better. But we don't rely on a central guy to exist. Okay, these handles that you generate, they can be generated without the other process, any communication with the other process. So we don't need a name server. Okay, that's one difference. How that all happens is something we'll see later. But the basic idea is that you just hope that the guy's registered it. There's no guarantee. You send the name across, you know the name. And if the name is not bound to any object, you'll get back a message saying, sorry, you sent it to the wrong guy. Okay? So we don't have to need, so we're going to still, again, have a server like we did in the first demo. Let's start Alice again. Okay, now let's look at something interesting. Before I even start, Bob, notice all this stuff I'm seeing here? This is the most interesting part of this project, by the way, from your point of view. I mean, you use my system. So you will do this project in two parts. You will first use GIPC, okay, which has got a different communication abstraction, where you don't do blocking procedure calls. You do a non-blocking procedure calls, so that you can get the benefit of not having to deal with streams, and yet also the benefit of low latency. I mean, not waiting for the message, okay? That part, you just have to go and, use a different kind of infrastructure. That's not a big deal. In fact, your RMI program will work just directly with GIPC. The more challenging part, which we talked about, is the serializer, okay? And now, what did you say we are serializing in this application? Strings. But you see that this is more complicated. See what I'm serializing? So by the way, here the serializer that I'm going to write is not going to be one little object. It's going to be multiple objects talking to each other. Okay, so there's going to be this object in charge of this part of serialization, another object in charge of another kind of serialization, and so forth. So you see here that I've got a custom serializer, an abstract serializer, a bean serializer, a string serializer, da, 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 da. That's what's going to make this project challenging, to have this recursive algorithm that's distributed among multiple objects. It's not going to be distributed in terms of, different processes, but it's distributed among multiple objects. Okay? That's the fun part. Now, notice that, there's a string serializer. Shouldn't I just need a string serializer? Why do I need anything beyond a string serializer in this application?
Because you need a structure.
Sorry?
Go ahead. You need to probably make the other things into strings so that you can use the string serializer.
But what other things are we sending? I'm just sending my commands, yeah, right? That's nothing.
Well, structures with like what the arguments are. And,
so arguments. I'm calling procedures, right? So a procedure is something that you put on the stack, right? There's an activation record. You go and say, here's the arguments, here's the return value slot. That's a record, which has to now get serialized into a message. And then the return values have to come back. So what I'm sending as far as the serializer is concerned is a serializable call. It so happens that the call has string arguments, but the call itself is a structure. Okay? So you see, the abstract serializer goes and says, hey, I have to make a serializable call. Okay? Then it says, you know what? For each kind of object, a different kind of serializer has been registered. This happens to be a bean object. Okay? A bean object is an object with properties. So I will go and find the bean serializer. Okay? The bean serializer goes and says, okay, I have divided the bean into these properties. So I'm going to call the abstract serializer on each of the properties, saying, okay, now you do it. The abstract serializer is going to say, oh, is it a string? Is it a double? Is it an array? Is it a bean? Which is all going to be registered somewhere. And if it's a string, it says, okay, go string serializer. If it's a bean, it says, okay, another instance of the bean serializer, go and serialize this. If it's an array, it says, go array serializer, serialize it. Okay? And you guys have to write a serializer that will serialize everything that's needed to make a procedure called abstraction work. Not just strings work, but whatever is needed for which there are enums there that I use to go and figure out, to mark data, mark things. So this is going to be a really fun thing where now you're no longer building an application. You're no longer just using an abstraction. You're actually building an abstraction, which is the serializer. Okay, you'll do it in two parts. You will first use GIPC with the native serializer, which happens to be the Java serializer. But I've gone and structured it so that it can be just pulled out, and you can put your thing in. Okay?
So this is the final?
No, this is not the final thing. Okay, the final thing is going to be the most fun part. The final thing will build on top of this. So last time when I taught this course, I had 5 assignments. I've taken 2 out, and I've added 1 more. Okay? So everything I've done, I'm showing you so far, has been done before. Okay? Question? Okay. That's the main part here. Let me just show you the asynchronous part also. So by the way, this is all communication that happened when this Alice registered itself with the session manager. Actually, we haven't even sent data to another process so far. We haven't sent the command. Beyond the string commands, we're also registering ourselves with the session manager saying, by the way, my name is Alice. Here's the object that I'm passing to you, where I want to receive callbacks. Okay? And so that's what's happening here. Now let's go and start Bob.
So result of a serialization isn't like when we serialize, we make it a string, right?
No. When we serialize, we make it into a stream. If you want to be efficient, you don't make it into strings. But for your debugging purposes, you may well want to make it into strings. Okay? You're just serializing it. You know, exactly what happened in the first demo with NIO, where we took the bytes and converted that string and converted to bytes. Now we're taking strings and ints and so forth, and there's a network representation of ints. So there are network standards on what an int is on the network. So you don't have to convert it into a string. Just imagine if the number 1000 can be sent in 1 byte versus 4 characters. Okay. So now you notice that there's the server knows that Alice has opened it and so forth. So we've got this going here. And now let me do some of the same stuff that we did earlier. Notice I've got the same UIs, by the way, for all 3 applications. They are different structures. So I did a lot of reuse here. Okay? And from a software engineering point of view, you guys might want to, just a challenge, see whether your demos can all use similar loops to go and execute the commands one after the other. I'll be asking you to do that. That please execute these commands in a loop. Okay, and try to make sure that the same code, same object can be used in all 3 demos. It's not easy. Okay, and that's just okay. So I'm going to say wait for relay again. Okay, and now I'm going to say move 50 minus 50. Notice this guy moved immediately. Okay, it's an asynchronous procedure. It's an asynchronous call. And notice now, I never answered the question for RMI. What is that thread that gets blocked? Okay, in RMI, you saw there was a TCP connection word in there. For each client, it creates a separate thread. Okay, so if I'm the server and I'm connected to 5 clients, for each of us, we'll create a separate thread. All your calls will come to your thread. All your calls will come to your thread, and so forth. There is fewer guarantees as a result, because the different calls aren't getting serialized. So what I do in GIPC is have a single thread for all clients. That just gives you stronger consistency guarantees. Okay. So now when I do proceed, Bob gets the message. Okay. And similarly, Kathy would have got the message. So now we do have non-blocking, but with the procedure call abstraction. That's the point. That's the point of GIPC. That's not what you implement, that's what you use. But you will study in class so that you will understand that there's a notion. And in fact, I built on top of NIO. So it's just a layer above NIO. And I did all the things I'm telling you about. I kept track of the size. I tried to make sure. It's a real pain to code that. Make sure that, if you get early bytes, late bytes. Okay, question.
I have a question. So do you have a thread pool back on the relayer? You say you only have one thread servicing the request.
Yes.
Right.
Yes.
You don't have a thread pool.
But if I have a thread pool, then the serialization becomes an issue. This whole atomic broadcast idea becomes an issue. I can always delegate. See, from one thread, I can go to multiple threads, always.
Yeah.
From multiple threads, I can't go to one thread. If inherently every connection gets messages in one separate thread, I can't combine them into one thread unless I go and put some kind of synchronization methods, and each thread goes and puts it into another bounded buffer from which a process goes. But a single thread can always go and say, okay, I'm sending this information, A to B, A to I goes to this thread, J to L goes to this thread. So it's always possible to do that. Okay? But I just did not want to make it the default so that I have more consistency guarantees. And you realize if I have a thread pool, then we don't know in what order messages will be received at different clients. We won't have an atomic broadcast.
But we have but thread have a shared memory, so you can share the state.
But then what have I gained? If I'm going to make them wait for each other, what have we gained? If I'm going to make them wait for each other, yes,
okay.
then what's the point? The point is I do want to send things one at a time.
Okay, I see.
It's called a sequencer. This relayer is called a sequencer. I want a sequence. Okay?
So basically, you're saying you will perform some operations with a sequence of sub operations, and you wanna you somehow save the states for this operations.
No, hang on. No, we are not saving state. We are just sending the messages. We're just relaying the messages blindly. We don't even know what's inside the messages. We're just making sure that each process processes these messages in the same order.
Yeah, I understand the server doesn't save any states,
Yeah.
but the client, from the client view, the client wants some kind of states, right?
Yeah, client has state. Client gets commands saying do this, do that, do that. Whatever the next command is, it executes blindly. It doesn't know that the command came from the local guy, the remote guy. It just knows, I got to execute this command.
So the server has just one, or it has one thread for each process or other client that is connected to. And
That's what happens in RMI.
Oh, sorry.
My guy has one thread for each session.
For each session. Oh, okay.
That's what RMI has.
Yeah.
RMI has a thread for each client.
Just got a little confused there.
Yeah. And you guys are learning the whole course in half an hour. That's what's happening here.
The reason I asked that question is I saw some asynchronous framework has the worker pool
Yes.
underneath, and then do some work when the load is very heavy.
If I'm getting Google searches, where your Google search and your Google search have nothing in common between them, I will do that.
Okay.
I am trying to do something where there's a consistency issue. Okay?
So for a session, like you're receiving one command, like you have the master process that works off some other process that handles this one command, and it's that process that then broadcasts.
Okay, okay. No, the master process. See, all this guy is doing is getting a message and sending it across, right?
Mhm.
And multicasting it.
Mhm.
So this guy just simply goes and doesn't even fork process. Okay, it just goes and sends it across. What happens there?
But didn't you say you created a new process for each session?
For a session, session means a group of people,
Oh, okay.
not each command.
Oh, okay. That's what I thought you meant.
No, no, no. A session means, I am the relayer for this Halloween session. There might be another 5 users playing another game.
Mhm.
For them, I can have different threads.
Okay.
That's what happens in Gypsy. Okay, when we talk of sessions. Actually, we haven't talked of sessions. Right now, Gypsy doesn't, it's just one-on-one communication. We'll talk of group communication next. Okay? Right now, it just knows there's a bunch of parties, and it just goes and sends individual messages to them. Okay. Let me backtrack a little bit. You can name people in a group. Okay, you can say this is Alice, this is Bob, this is Kathy, and that's part of a session object. Okay, but there's no group communication. You don't go and say, I'm sending messages to everybody. Okay, the client goes and sends a message to the server, and the server just goes and relays it back to everybody else. It's not grouped that way. Okay, and I'll show you next how that's going to happen, which is a more P2P kind of way, where I go and send messages directly to a bunch of people, and that's sort of P2P session management. Whereas this is more like relayed session management, which is much simpler. It's really, very hardwired kind of thing. Okay. Okay, so we've gone to 3/4 of the course. Okay, now we're going to go to the last 1/4 of the course. And this, guys, I want to start 4 processes because I want to show fault tolerance. And this little area I have is just so small. Bear with me. Okay, let's go and end the recording.